just in case. Number 11. Oh wait, was somebody else gone? Oh, Craig was.
Who's Craig?
Craig is the guy that sits right next to you.
No, that's Alex.
Cubert of 2/3.
No, Alex.
I totally forgot.
I miss Carl.
Yeah.
Okay.
It's kind of weird without him.
James is kind of. I mean, he's quiet, but he's alright.
Cubert of 2/3. So
He looks more of a dog.
this, when you have a cube root or like a square root of a fraction, really what this means is the top is in the cube root and the bottom is in the cube root. Okay, that's only part of the problem. The other problem is, how do I get rid of a cube root in the denominator?
Times, but.
Okay,
Right.
if I times it by itself,
Wait, that's not gonna do anything.
I would get a cube root of 9. Does 9 have a cube root?
No.
No. So really what I need is something that does have a cube root. 3 times 3 does not have a cube root.
You have to make the cube root of 9.
But 3 times 3 times 3 does have a cube root. So I could put times another cube root of 3, or I could just do it in one step and say times cube root of 9. You guys know why I chose 9. Right, because basically this is 3 times 3 times 3. I could write times cube root of 3 times cube root of 3, like twice, like this. But really, I'm just multiplying by cube root of 9, because that's what this amounts to. Basically, 3 times 9 is 27, right? And 27 does have a cubed root, so it's going to work out nicely. If I multiply the bottom times cube root of 9, then I need to multiply the top times cube root of 9. So the top is cube root of 18. Okay. Does cube root of 18 simplify?
No.
No. Remember, if it was square root, it would have, but cube roots have to have a triple in them, not a double. Anyway, it doesn't simplify. The bottom is cube root of 27. What's the cube root of 27?
3.
Normal 3. Does cube root of 18 over 3 reduce?
Yes.
No.
No.
A square root or a cube root and a normal number, they don't divide or multiply nicely. Unless if you change them into a decimal, yeah, you get some messy decimal answers. But we are writing the exact quote unquote answer. We're leaving it as a cube root. Whenever the book says simplify, that means that's what they want you to do. Unless they specifically say change it to a decimal and round it to the 10th place or something. 13. 2 cube root of 8 over cube root of 2. Alright. There's a hard way to do this one and a much, much easier way to do this one. Any ideas? Now that I've said that, am I scared you guys off? I put the wrong group there. What'd you say? Liar. You probably, I think you might have said the right thing. These two, the simple, okay, I could multiply the bottom by cube root of 2, cube root of 2, right? So it'd be cube root of 8, which actually has a cube root. Cube root of 8, this could turn into a normal 2. We don't actually want to do that though, because the easiest way is actually just reduce these. Those, since they're both cubed roots, you can actually divide those. Guess what cube root of 8 divided by cube root of 2 is?
Cube root of.
Cube root of 4. So
2 cubed of 4.
yes. Does cube root of 4 simplify?
No.
No. So that's all we can do. You guys know what the smallest number is that has a cubed root?
8. Right?
Well, yeah. Well, technically it's 1. Cubed root of 1 is still 1. 1 times 1 times 1 is 1. But 8, cubed root of 8 is 2. Cubed root of 27 is 3. 64, cube root of 64 is 4. Cube root of 125 is 5. They really don't usually go beyond that. Cube root of 216 is 6. They don't usually get much bigger. So yeah, there are different routes to take on some of these. 3 over 7 to the 3/4.
That's not fun.
I think we probably forgot what 7 to the 3/4 meant. Let's change it into radical form. You guys remember what 7 to the 3/4 meant?
Fourth root of.
Yeah, the 4th root of 7 cubed. Yeah, that's what it meant. It's a challenging one.
We can give up.
You ready to give up?
I'm always ready to give up.
Okay. I don't want the radical. How do I get rid of the radical? Well, since it's a 4th root, I need 4 of something.
One more sword.
Yeah, it needs one more 7, because I already got 3. So if I just multiply by the 4th root of 7, that's going to work. You guys see how I figured that out? You don't really need to figure out what 7 times 7 times 7 times 7 is, because whatever that is, once you take the 4th root of it, it's going to go back to 7. So basically what happened was the bottom becomes the 4th root of 7 to the 4th, but this is just a normal 7. Does that make sense? 7 to the 3rd times another 7 makes 7 to the 4th. Put the 4th root of that component. So anyway, I also need to multiply the top by 4th root of 7. So the top is 3 times the 4th root of 7. And the bottom is actually just, I'm going to get rid of that and turn that into a normal 7. I don't think any calculators in here can do that. I don't know what calculator you could find that would. You gotta be pretty smart. Once you get past square roots, that's kind of when you start losing calculators. Anything past the square root. Number 17. Okay. I think I mentioned this briefly the other day. We probably forgot what it was. They're asking for what's the conjugate of this thing. You guys remember when we foiled conjugates? I don't know, it's probably like 4 or 5 days ago.
Oh, yeah.
So this is the question, not the answer. So the conjugate of this would be, you just switch the middle. Is 7 minus square root of 2. That's it. So these are going to go really quick. Number 19, 3 minus 4i. Guess what the conjugate of 3 minus 4i is?
Plus.
3 plus 4i. So notice the sign on the front term doesn't switch. It's just the sign in the middle switches. From plus to a minus or minus to a plus. There's some easy points for you guys. Followed by some hard ones. How far did I say we're going? 28? Okay.
Is that 28 or a
That's
5?
an 8. How do you get a 5 out of that?
I could see it.
I mean, it starts to fade out, but does that really look like a 5 though?
Yeah.
From here it does.
Yeah. 21.
Does that 8 even have like a top?
I'm also blind.
I don't. It's only got like one circle on that 8. You guys are hot. It looks like a perfect.
Let's talk for 5 minutes about the.
It does sound like cursive, or like not cursive because it comes out round the wrong way.
It's not an 8, I can tell you that.
No.
I know one thing. Okay. Now there's a couple ways we can do this. There's a couple routes. What do you guys think? We could simplify first.
Reduce.
Actually, reducing first doesn't actually make it go any faster. Since that's probably what most people would do, what would the top reduce to though, if we reduce this?
2, 4, which is
Well, 4 and 8, how does 4 and 8 reduce?
1/2.
Yeah, 1/2. So it really becomes like the 4th root of 1 and the 4th root of 2. But what's the 4th root of 1?
1 times
1. Because 1 times 1 times 1 times 1 is 1. So just a normal one. The top is the 4th root of 2. Here's the problem though, I want to get rid of my main issue is I need to get rid of the radical in the denominator. Okay, so I got 1, 2, that's a prime. I need something that has a 4th root.
So the 4th root of 2 to the 3rd.
Yeah, so basically I need 3 more 2's. Times 2 times 2 times 2. What's 2 times 2 times 2?
2 to the 3rd.
8. So you could say it's 2 to the 3rd, or you could just say it's 8. It's probably better to write 8 because that's the simplified version.
Now I'm pretty dumb, so don't confuse me.
So the bottom is the 4th root of 16, which is guess what?
4.
No.
2.
2. This is made up of 4 2's if we multiply all these together. 4th root of 16 just comes out as normal 2. That's why we did it, so it would come out as normal 2 on the bottom. The top is now 4th root of 8. How's this going? Is this painful? Are we getting any of it? The easier version of that problem was we could have just started by multiplying the top and bottom by 4th root of 2. Because then that would turn that into 4th root of 16. So we could just multiply by 2. I think. Yeah, that would have been easier. It's kind of something you kind of get used to if you do a few more of them. But anyway, 23. 5 minus square root of 5 over square root of 7. This is not that different from like number 1. So, what should we do? Can't leave square root in the bottom, so what do I do about it?
Multiply by square root of 7.
Right. The only difference between this and number 1 is its distributive property on the top. We need to do square root of 7 to the top. So the top becomes 5 square root of 7 minus
square root of 35.
square root of 35, which does not simplify. Square root of 35 is 5 times 7. There's no doubles in that. The bottom becomes square root of 7 times square root of 7 is 7. Yeah, we're doing all right. Not that
How do we have?
21,
I'm starving.
28.
I want
Starving?
crappy Weston school pizza. It's pretty bad. I mean,
No, it's actually pretty good.
they only had like 3, or no, they start with like 3 flavors and then it funnels down to about 1.
Flake
They don't have those. You can get
flavors.
not flavors. I mean styles. No toppings.
They started out
Okay.
with 3 pizza flavors.
Screw you.
Shh. Okay. So, I need to pause for a second and talk about something that's kind of important.
The economy.
No.
Oh,
I
wait,
feel
the
like
bottom's not done.
No, it's done.
America.
That was it.
Okay, I was like,
Those do not reduce, right? Because those are square roots and that's not. So that does not reduce. Okay. This, we've talked about this before, but I probably need to go over it again. Does this reduce?
Yes.
Yeah. If you can divide both terms, or if there's 3 terms, if you can divide all the terms by 5, then you can go ahead and do that. This would be square root of 2 minus 2. Okay. What if I do this?
oh,
Okay, this does not reduce unless you split them up. You could say this is because this does not divide well. You could say this is square root of 2 minus 12/5, but that didn't really reduce that part. Or you can just leave it like that. So if terms are added or subtracted, everything needs to be divided by that. If stuff is multiplied together, you can divide that out, like that part. But if it's added or subtracted, it's got to work in both. Anyways, that's always trouble. What number are we on? 25?
Yes.
Almost there, folks. We're getting close. 8 over square root of 5 minus 6. I probably should have signed more of these, to be honest.
No,
Thank
Okay,
you.
this is the first one of its kind. Okay, if I multiply by square root of 5 on the bottom, what's going to happen?
It's just gonna turn it into 5 times negative, not 5 minus 6.
It'd be 5 minus 6 square root of 5, which does not get rid of my square root. So, if I keep multiplying by square root of 5, it'll still have square root of 5 over here. It doesn't solve my problem. So, if I have two terms in the denominator, I actually need to multiply by the conjugate. What's the conjugate?
Square root of 5 plus 6.
Square root of 5 plus 6. Because we did this the other day when we were foiling. When you multiply conjugates together, the outside and inside cancel each other out, and that'll get rid of our square root problem. So basically, if there's two terms in the denominator, instead of just multiplying by square root of 5, I do square root of 5 plus 6. If I do that on the bottom, I have to do that on the top. The top is distributive property, basically. 8 square root of 5 plus 48. The bottom, okay, you can do the whole FOIL, but what you're going to find out is that the outside and inside will always cancel each other out. So really you only have to do first and last. First, what's square root of 5 times 5?
5.
5. So let's go ahead and look at the outside and inside. Outside is 6 square root of 5, inside is minus 6 square root of 5. Those cancel out. What's the last?
Negative 36.
Negative 36. So I really just have 5 minus 36, which is negative 31. No square roots in the denominator. Since this was just a square root problem, that means the good calculators can probably handle it. 27, 2 square root of 3 over, I forgot already, 6 square root of 6 plus 2. So guess what we're going to do on this one?
Conjugate.
Conjugate. Square root of 6 minus 2 will be the conjugate. So the top, what's 2 square root of 3 times square root of 6?
Square root of 18.
2 square root of 18. Now, we'll have to come back to that because square root of 18 is actually big enough to simplify. 2 square root of 3 times 2 is, 2 times 2 is 4 square root of 3. Okay, on the bottom, since they're conjugates, we really only need to do first and last. What's the first? Square root of 6 times square root of 6?
6.
Last?
Negative 1.
Minus 4. Okay, square root of 18 turns out to be 3 square root of 2. So 2 times 3 square root of 2 is 6 square root of 2. So that goes right there, 6 square root of 2. Minus 4 square root of 3 over 2. Can I do anything else? Yes, I can. Both these terms are divisible by 2. Divide both those by 2. So it's 3 square root of 2 minus 2 square root of 3. Good luck, Godspeed. I'll check some if you want me to, or help you. I can't find my mouse.